So we're going to be solving equations that contain rational expressions. So far, we've been simplifying expressions or adding expressions or multiplying them, dividing them, things like that. So the difference between an expression and an equation is that an equation has an equal sign in it. So you can tell right away with what you're presented with whether it's an expression or an equation. Expressions do not have enough information for you to find a value of x. You can find what x can't be in an expression, but you can't know for certain what x is in most expressions. In an equation, though, we're setting two things equal to each other, and that often gives us enough information to determine what x is. So what we've been doing so far is working with expressions, and today we're going to look at solving equations that have radical expressions in them. So solving equations. The first thing we want to do when we have an equation, notice the equal sign, that has a fraction in it is get rid of the fraction. Now we've done that before when our fractions were just numbers. But since we're talking about rational expressions, those have a variable in the denominator. So this simple one right here, the 5 over 3x is what makes this a rational equation. But we're going to do the same thing we did before. We're going to multiply to get rid of the fractions. Both the ones that have numbers in them and the ones that have variables in them. So the thing we want to multiply by is the least common denominator. Now any common denominator of all the terms in the entire equation will work. But we want the least common denominator because that's going to require the least amount of work to simplify it in the end. Okay, so to get the least common denominator of 3x and 1 over 1, so 1 and the 6, we need to think about all the factors, right? And so we need a 3 and an x for sure. 1's always there, so we don't have to worry about the factor of 1. But then I need both the factors of 6, the 2 and the 3. I already have the 3. So I just need a 2. So I have 3 times x times 2. And you can call that 6x if you want. That's not a problem. Just trying to show you all the factors there. Then we're going to take each term all the way across the equation, and we're going to multiply each one by that least common denominator. So I have 5 over 3x. That gets multiplied by 3 times x times 2. I'm going to go ahead and simplify this one. Simplifying this rational expression is what you did in a previous lesson, right? We know that if we have a factor of 1 when we're multiplying, like 3 over 3, we can cross that off. X over x is also a factor of 1. And then multiply what's left, just 5 times 2 in the top, so that gives me 10. Then I'm going to go to the next term, which is just 1, and 1 gets multiplied by 3 times x times 2. So 1 times 6x is just 6x. Now I put my equal sign and I go to the terms on the right side of the equal sign. So I just have 7 over 6, and that gets multiplied by 3 times x times 2. Those are all multiplied together. So I know the 3 times 2 is 6, so this 6 that's in the numerator is going to cancel with that 6 in the denominator as a factor of 1. Or I could factor 6 into 3 times 2 and see 3 over 3 is 1 and 2 over 2 is 1. And then multiply the things that are left over. The 7 times the x gives me 7x right here. Now if I get to this point and I still have fractions, then I did something wrong. Either I made an arithmetic mistake or I didn't multiply by a common denominator. You shouldn't have any fractions left over at this point right here. So I've changed my somewhat complicated equation into something that's easier to solve. So now I just need x's on one side, numbers on the other side. I'm going to subtract 6x from both sides. Those are like terms, so that leaves me 1x. And then on this side I'm just left with a 10. So that's a 0. And x is equal to 10. And that's my answer. Now I do have to check on rational equations. I have to check to make sure that the answer that I get for this linear equation right here, after I simplified and multiplied by that least common denominator, that this answer that I get doesn't cause me to divide by 0 in any of my original fractions. So if I put 10 in for the x right here, 3 times 10 is certainly not 0. And that's the only place that I have an x in the denominator, so I'm good with x equals 10. I can keep that answer. Okay, that's the only possibility for an answer. It doesn't cause me to divide by 0 in the original equation, and so that's the answer. But you do have to have that extra step of checking. You don't have to check the whole equation for truth. You just need to check to make sure that the answer you get doesn't cause you to divide by 0 in the original. So earlier in the chapter, much earlier in the chapter, when we were looking for excluded values, and we were interested in what makes that denominator equal to 0, that's where this comes into play again, or where that comes into play. Okay, so you have to remember to check for that. Let's look at another example. This time, my rational expressions look a little more complicated. I have more rational expression. Every term in this equation is a rational expression. But my process is the same. I want to multiply by the least common denominator to get rid of all the fractions and just solve what's left. I could multiply by 2 and x in this group x plus 1, and then I can multiply by 3x squared plus 3x, but that's not going to be the least common denominator, and if I do that, then I'm causing a lot more work down below later in the solving process. So I want to make sure I factor first. You can't factor 2x anymore, so that's done. You can't factor x plus 1 any further, okay, but the 3x squared plus 3x has a common factor of 3 and x in each of those terms. So I want to rewrite this in its factored form. I'm going to write the 3x, which is the common factor. I'm going to put the leftovers for each term in the parentheses. So 3x squared divided by 3x leaves me an x, and 3x divided by 3x is 1. Okay, that's why we did the factoring in the last unit. So this is a good place to review that. Now that I have every denominator factored, it's easier for me to find the least common denominator. I know that it's got to have every factor of the first denominator, which is 2 and x. And it has to have every factor of the second fraction, which is x plus 1. And it's got to have every factor of the next denominator. But I don't want to repeat any factors. I need the 3 because there's not already a factor of 3. But I don't need to repeat the x because it's already there. And I don't need to repeat the x plus 1 because it's already there. Highly encourage you to write out that least common denominator over there, the thing that you're multiplying by. Don't try to carry too much stuff in your head because it's easy to lose it up there. Now let's do the same thing that we did before. For each fraction, or even if it's not a fraction, for each term, we're going to multiply by that least common denominator. So if I take 1 over 2x, and I multiply by 2x times x plus 1 times 3, I can see that the 2 over 2 is a factor of 1. The x over x is a factor of 1, so I can cross those off. And then what's left is a 1, the group x plus 1, and a 3. So I just need to multiply those back together. So I have 3x plus 3. Then go to the second fraction and do the same thing. Now I have a minus in between there. You can either take that minus with the numerator, or you can just remember it as you're multiplying these things together. So I have 1 over the group x plus 1 that gets multiplied by the least common denominator, 2x times x plus 1 times 3. We can group this whole denominator, and then that is the same factor in the numerator. So x plus 1 over x plus 1 is a factor of 1. It crosses off the same way that 2 over 2 did, or x over x did in our first term. Now look at what's left. I have this negative 1, a 2 times an x times a 3. So I just need to multiply all those back together. So that looks like minus 6x. Don't lose your equal sign, because this is an equation, and where that equal sign falls is very important. And then let's go to the other side. So I have 1 over 3x times x plus 1 multiplied by 2 and x plus 1 and 3. Look for all the factors of 1. X plus 1 over x plus 1 is a factor of 1. x over x is a factor of 1, and 3 over 3 is a factor of 1. And then the only thing that's left is 1 times 2, which is 2. So we took that rather complicated equation that we started with and we made it into something that's a whole lot simpler. The highest power of any of these is x to the first power, so I can combine like terms. A 3x and a negative 6x is a negative 3x. And then I have this plus 3. I'm going to go ahead and subtract that to the other side. Now to get x by itself, I just want to divide by negative 3. So x is equal to negative 1 divided by negative 3, which is positive 1 divided by positive 3. X is equal to 1/3. So if there's a solution to that equation that I was originally given, then this is it. But I need to check and make sure that that doesn't cause me to divide by 0. Now the check is pretty easy to do. I don't have to figure out what the denominator is equal to. I just have to know, is it going to equal 0? And so if I substitute 1/3 for the x in this first denominator, I have 2 times 1/3. I don't really care what that is as long as it's not 0, and it's not 0. And then if I take this x right here in the second denominator and I substitute 1/3 for that, then I get 1/3 plus 1, definitely not 0. And then when I go to the next one, I have 3 times 1/3. Those are reciprocals, so that's 1. That's definitely not 0. And then 1/3 plus 1 is not 0. So there's no way that 1/3 makes that last denominator equal to 0, and that means that this checks out. This is my answer. So you get kind of lulled in a false sense of security that, oh, I'll just get the answer. I don't really need to check it. But no, you have to check it. Okay, you have to. It's not optional, because there will be times, as soon as you get lax with it, where you're solving a linear, or especially you're solving something that's quadratic, and it turns out that one of your answers causes the original equation to have a divide by 0 in it, and that just means that's not a solution. Okay, so we worked through 2 examples, or I have, and you followed along. And what questions do you have so far? And let's go to this one. That doesn't look too bad. Let's see what happens. It is rational. Because, do you have this problem? Is it on your paper? Yeah. Okay. So, I have a fraction equal to a fraction, and I have x in the denominator in both of those fractions. So I want to multiply by the least common denominator. And I notice that those are very similar, x minus 1 and x plus 1. They are similar, but they are not the same. So my common denominator is going to have to include the group x minus 1 and the group x plus 1. Okay, neither one of those can be factored individually any further. So I have to have each of them as a group, as a factor, in my least common denominator. So now let's take our first fraction, 1 over x minus 1, and let's multiply it by x minus 1 times x plus 1. And then that's going to equal the term on the other side, 2 over x plus 1 times x minus 1 times x plus 1. So every term gets multiplied by exactly the same thing, but they're going to simplify differently because of what's in the denominator. So the fraction bar is a grouping symbol, and that groups that x minus 1, but I can group it further by putting parentheses on it, and I see that I have an x minus 1 factor on the top and the exact same factor or group on the bottom. So I cross those off as a factor of 1, I simplify those, and that leaves the original numerator of 1 times the factor that's left over, x plus 1. So that means x plus 1. And then on the other side, do the same thing. This time my denominator is x plus 1, and it's going to cancel the exact same group, x plus 1, in the numerator. And I have left over a 2 times the factor x minus 1. So I need to distribute that 2 through that group. 2 times x is 2x, and 2 times negative 1 is minus 2. Again, it turned into something that's linear. I just need to get x's on one side, numbers on the other side. So I'm going to subtract x from both sides. I'm going to go ahead and add 2 to both sides. That's not the only series of steps that you could take to solve this. As long as you get x's on one side, numbers on the other side, you'll be good. So that's a 0, this is 3. This is a 0, and this is just x. So x is equal to 3. If I substitute 3 into the denominator of the first fraction, I get 3 minus 1. That's not 0, so that's okay. If I substitute x equals 3 in the second denominator, I get 3 plus 1. That's not 0, so that's okay. So this one checks out. Okay, just one more. So in this problem, I see a 9 minus a squared. I can group those and I can make that a factor, but I want to make sure it's factored all the way. Do you notice anything about 9 and a squared and the fact that they're subtracted? Difference of perfect squares? Okay, so your a squared, that's a perfect square, a times a. What about the 9? 3 times 3 is 9. When you have the difference of squares like this, it will factor. And it will factor into conjugates. Remember, conjugates have the same first term, the same second term, but the signs in between are different. So a 3 plus a and a 3 minus a. Okay, that's what conjugates are. So we're going to use the factored form of that first denominator. And then we're going to multiply by both of those factors, 3 plus a times 3 minus a. And then when I look at my next fraction, I see that I need a factor of 3 plus a. Well, I already have it, so I'm not going to repeat it. And when I look at the next fraction, I need a 3 minus a, and I already have it, so I'm not going to repeat it. So the only factors I need for this simplification process are the ones that come from the 9 minus a squared. But I really don't know that for sure until I have it factored. So now let's multiply it together. If I multiply 12 over 3 plus a times 3 minus a times 3 plus a times 3 minus a, do you see that you've got two factors of 1 there? What are you left with when you do that multiplication? We can write it out. 12 over 3 plus a times 3 minus a multiplied by 3 plus a times 3 minus a. That's a factor of 1.
You just get 12?
You just get 12. That's a factor of 1. So you don't have to actually write this middle step that I've been writing unless you need to, right? Don't make mistakes because you're not writing it. Don't think that if I cancel it out in the first fraction over here that it's gone. I have to reuse that least common denominator for every term all the way across. But that doesn't mean you have to write everything. But if you want to write it to stay safe, then you can do that. So if I multiply the second fraction times our common denominator, this time just the 3 plus a on top and bottom are going to cancel. And then I still have this plus 3 multiplied by 3 minus a. I'm going to go ahead and distribute that. So plus 9 and then plus 3 times negative a makes minus 3a. And then we're on the other side of the equal sign. 2 over 3 minus a times 3 plus a times 3 minus a. This time the 3 minus a is the common factor on top and bottom. So this is that simplifying process that we were doing when we were multiplying rational expressions earlier in the unit. It helps us to solve equations now. So there's our factor of 1. We're left with 2 times the group 3 plus a. So let's go ahead and distribute the 2. 2 times 3 is 6. 2 times a is plus 2a. Plus signs, minus signs, equal signs are very important. If you lose any of those, then it kind of puts you in trouble for getting the right answer. So let's combine like terms. So we have 12 plus 9, which is 21, minus 3a is equal to 6 plus 2a. I'm going to add 3a to both sides and subtract 6 from both sides. You might choose to do something different, but as long as you're getting your letters on one side, your numbers on the other side, then you're okay. 21 minus 6 is 15, and then that's 5a. Divide both sides by 5, and I get a is equal to 3. So that's it, right? That's my answer. Is there anything wrong with a being 3? what happens if I let A be 3 in this denominator right here? I get a 0. Okay, so that was the only possibility for an answer, and that's not an answer. So that means that my answer is, I can't do this, the empty set. I could do this, but in Delta Math, which is your assignment, they're going to want this, but they're not going to want you to type that. Either one of these represents the empty set. Okay, so in other words, no solution. So what you're going to do in your Delta Math to get these little squiggly brackets is you're going to click the minus sign to take away the only answer box you have. And when you do that, it's going to give you the squiggly boxes, the squiggly brackets right there. Okay, so I gave it away. Your practice is in Delta Math. There aren't a lot of questions on that. Okay, I think there are 6 questions that you have to do. For every one you miss, you work another one until you get it right. If you feel like that's not enough practice, then I invite you to do more, because it's not ever going to lower your grade in Delta Math like it does in IXL. It's only going to give you the additional practice that you feel like.